Brainstorming. Our brainstorming involved drawing and collaborating our initial ideas before conducting any research. We came up with a design that utilized the maximum dimensions. We did this to have the most surface area touching the water to help with buoyancy. As well as having a large surface area, we wanted a small rib on the underside of the hull to prevent the canoe from tipping. Background research. In an industrial setting, concrete has steel reinforcements to provide for structure and improve strength. We decided to implement similar lattice into our canoe idea. As well as using wire lattice, the places where concrete is kept and time for concrete to set are important. When concrete is set in, it should be kept in a moist, controlled environment. There are a few key parts of a canoe. They include the keel, the gunwale, the ribs, the deck, the thwarts, and the hull. Because canoes are long and skinny, we decided mimicking this was very important. Canoes have supports that span the hull called thwarts. The purpose of thwarts in a canoe is to prevent the canoe from warping. When a canoe warps, it becomes significantly less buoyant. Although thwarts are important to the buoyancy of canoes, it is against the criteria of the FED project. Therefore, we couldn't implement thwarts in our design. Materials. The materials we used were lightweight, low aggregate, sand mix concrete. We used this because of easy workability and lightweight. The lightweight helps with buoyancy. We also used half-inch wire lath for reinforcements, as well as green styrofoam used to mold and form the concrete for the shape. Some other extraneous materials we used were duct tape, water, and plastic wrap. Building process. Prototype number 1. For our first prototype, we used the wire lattice to form a mold and some green styrofoam to make a negative. Upon testing this model, it sank like a rock. Some errors with this canoe were the overall shape. It wasn't completely symmetrical, and this caused it to lose buoyancy and sink immediately. This led us to make prototype number 2. Instead of using the wire lattice as a mold, we decided to make a styrofoam core and form the concrete around it. We cut and shaped the styrofoam to the desired shape and then covered it in duct tape to protect it from water and the concrete. We then taped strips of wire lattice to the mold to provide stability and rigidity. After covering the styrofoam in concrete, we made some final shape modifications and set the canoe aside and let it dry. Design testing. After the concrete set, we filled up a sink and tested our second prototype. It floats! Here are some images of the final product. Advice for future freshmen. First off, don't get stressed about your Fed group. At first, it will be hard to work together, but by the end, it'll be fun and very good learning experience. Second, don't procrastinate. No matter how easy you think your project will be, there will always be unforeseen events that can happen. Plan ahead and set aside time to get work done. Third, work as a team. Don't let one person do all the work. Assert yourself and share your skills and knowledge. Everyone has a place on the team. Fourth, be prepared for mistakes, and don't stress about them. There will come a time when it seems like nothing works, and you're up late panicking about the due date. Stay calm and work together. Finally, have fun and learn about different engineering principles. This is the beginning of the rest of your life as an engineer. Make the most of it. What could we improve? The main thing our group could improve on is time management. The collaboration required for this project is huge. Finding times to meet that don't conflict with everyone's classes is difficult. Our group could spend more time preparing beforehand and being prepared from the get-go. That way we are ready to accomplish things when they need to be accomplished. Overall, we are pleased with the canoe we produced and hope it does well at the Freshman Engineering Design Day.